Hello everyone. Today's topic is about IGCSE Chemistry, Chapter 2, Part 2, The Nature of Matter. Let's look into the Chapter 2, Part 2 outline. So, first of all, we have changes in physical states, effect of heat on kinetic energy, chemical reaction and physical changes, differences between mixture and pure compound, proton number or atomic number, nuclear number or mass number, subatomic composition and atom structure, and finally, isotopes. Let's begin. Changes in physical state. When a solid changes to a liquid, there is a change of state. Example, there is a change of state when salt, ice melt to form liquid water. When a liquid changes to a gas, there is also a change of state. When liquid water boils to form a steam. These changes are physical changes. No new substances are produced when the state of a substance changes. A change of state can be reversed. Example, liquid water can be frozen to form ice. During a change of state, the temperature will always remain the same. Let's look into melting. Melting is a process whereby when solid is heated, it gets hotter. Particles in the solid vibrate more and begin to break away from one another. The temperature at which solid turns to liquid is called melting point. Example, ice will change to water. Evaporation. When liquid is heated, the particles in liquid move faster as the temperature rises, and a few particles at the surface have enough energy to change into gas. Boiling. Boiling is actually eventually, as more heat is applied to liquid, temperature rises until it reaches its boiling point. At this point, the particles have enough energy to break away from the liquid to form steam. Condensation. The reverse of evaporation is condensation. When gas is cool, the gas particles lose energy. The particles move slowly. When they collide with each other, they do not have enough energy to bounce away. Then they stay close together to form a liquid. Freezing. When the liquid is cool, again, the particles slow down even more. Then they stop moving, just small vibration. The liquid will form a solid constant temperature, and this process is called freezing point. Sublimation. When iodine is heated, the particles get enough energy to change from solid to gas. The change of state is called sublimation. Sublimation also occurs when solid carbon dioxide, dry ice, is heated. The effect of heat on the kinetic energy of particles of a solid, liquid, and a gas. What will happen in a solid? In solid, strong forces of attraction hold the atoms of molecule together. The particles vibrate but cannot break free. Liquids. In a liquid, the molecules are close together, but they have enough energy to move about. And finally, gases. In a gas, the molecules are far apart and are moving so quickly that they do not really attract to one another. The kinetic energy of particle is directly related to the speed of the particle in motion. A particle moving faster, more kinetic energy than slower moving particle. Heat is a form of energy. When a substance is heated, it receives heat energy. Temperature rises. This heat energy causes the particles in the substance to move faster. According to kinetic theory, molecules move quickly when substance is heated. On heating, the molecule receives heat from the source. This increases the kinetic energy of the molecules. As the kinetic energy increases, the temperature substance also increases. Chemical reactions and physical changes. There are two types of pure substance, which is element and compound. Elements is actually a substances that cannot be chemically broken down into simpler substances, whereas compounds is a pure substances made from two or more elements chemically combined together. Substances can meet in a variety of ways. They can react chemically with each other. In a reaction, one substance can change into another. Example, copper carbonate is a green solid, but on heating, it changed into black powder. Based on the investigation, found that the gas carbon dioxide is also produced. So this type of chemical reaction, when compound break down to form two or more substances, is called decomposition. Some substances, although they do not conduct electricity when solid, do conduct when they are melted or in solution. In the process of conduction, they are broken down into simple substances. Thus, lead, bromide, a silver gray metal, and brown vapor bromide are formed. Neither of these products can be split into simpler substances. The opposite type of reactions, where the substance is formed by the combination of two or more substances, is called synthesis. In a chemical reaction, a new chemical substance are formed, and normally the process is not easily reversed and the energy is often given out. And in physical change, the substance involved do not change identity. They can be easily returned to their original form by some physical process, such as cooling or evaporation. Example, sugar dissolved in water, but we can get the solid sugar back by evaporating of the water. Another synthesis reaction takes place between powdered iron and sulfur. The two solids are finely ground and well mixed. The mixture is heated. The reaction mixture continues to glow after the Bunsen burner is removed. Heat energy is given out, so there has been a reaction and we are left with a black non-magnetic solid iron and sulfur. Let's look into the differences between mixture and pure compound. When a mix forms, first, the substances are simply mixed together, no reaction takes place. Whereas, when the compound forms, the substances chemically react together to form a new compound. And when a mixture forms, the compound of the mixture can be varied. Whereas, on the other side, when the compound forms, the compound of the new compound is always the same. So, number 3, when a mixture forms, the properties of the substance present remain the same. On the other side, when a compound forms, the property of the new compound are very different from those of the element in it. And finally, when a mixture forms, the substances in the mixture can be separated by physical methods such as filtration, distillation, or magnetic attraction. Whereas, when a compound forms, the compound cannot easily be separated into its element. Modern understanding is based on the atomic theory put forward by John Dalton in 1807. His theory that all matter was infinitely divided into small particles known atoms. Dalton suggested that a pure element, which means that all matter is composed of atoms. An atom cannot be created or destroyed. All the atoms of an element are identical. The atoms of different elements are different. Atoms are the smallest particles that take part in a chemical reaction. When a chemical reaction takes place, atoms of different elements join together to form compound. And atoms of different elements can combine to make molecule of a compound. This is a theory suggested by John Dalton. Proton number or atomic number. The main periodic table has 103 elements, although more than 112 elements has been discovered. Each of these elements has a number called proton number. This number represents how many protons in one atom of the element. All the atoms of the same element have the same proton number because they have the same number of protons. So the formula to get proton number is actually the number of protons in an atom. Atoms are neutral. The number of electrons in a neutral atom always be the same as number of protons. Example, the proton number in a sodium atom is 11. Hence, a sodium atom has 11 protons and 11 electrons. Second example, the proton number of oxygen is 8. So oxygen atom has 8 proton and 8 electron. The proton number determines the type and properties of each element. Example, proton number for hydrogen is always 1 and the proton number of carbon always be 6. Nuclear number or mass number. The nuclear number is the total number of protons and neutrons in the nucleus of an atom. Okay, this is the formula to get the nuclear or mass number. Is equal to number of proton, which is atomic, plus number of neutrons. Boron has 5 protons and 6 neutrons. So the nuclear number of boron is 5 plus 6 equals to 11. Okay, based on this formula above. The nuclear number determines the mass of the atom. The mass of an atom is determined by the total number of neutron and proton. Number of neutrons means that nuclear number minus number of proton. Atomic, the symbol is Z. Or equals to nuclear mass number in bracket A minus proton or atomic number Z. So these are the formula. An atom with a bigger nuclear number is heavier than an atom with a smaller nuclear number. Look at this example. So it's actually this diagram represents atomic structure of helium, oxygen, and uranium. So helium atom. Helium atom consists of 2 proton and 2 neutron and 2 electron. Whereas oxygen atom consists of 8 proton, 8 neutron, and 8 electron. You can count here, the total is about 8 electrons. And whereas uranium, okay, consists of about 92 proton and 146 neutron. And the outside this, it should be 92 electron. This is the proton atomic number and nuclear number, the subatomic composition and structure of certain atom. Normally, this will be given in the periodic table. But in this case, it's a subatomic composition and structure of certain atom. It's just example to show you how electrons is actually represent the same number of proton. If you can see here, proton, okay, the numbers here is the same as electron. Okay, and neutron is actually based on formula. If you want to get the neutron, it's actually the mass number minus proton, you will get the answer for neutron. Okay, based on the formula given previously, the neutron or mass number equals to number of proton atomic plus to number of neutron. So these are example of hydrogen, where hydrogen the symbol is H. If you can see, the mass number, atomic number is 1, mass number is 1, proton is 1, neutron 0. So the electron is actually 1. Also helium, the symbol is H, small e, lithium, capital L, I, beryllium, capital B, E, carbon, capital C, oxygen, capital O, sodium, capital N, and small e, calcium, capital C, small a, gold, capital AU, uranium is capital U. Isotopes. Atoms of the same element which have the same proton number but different nuclear number. That is the meaning of isotopes. Example, all carbon atoms have 6 protons. All oxygen atom has 8 protons, which is proton number equals to 8. And all carbon atoms have 6 protons. And some carbon atoms have 6 neutrons. So nuclear number would be 6 plus 6 equals to 12 nuclear number. And some have 8 neutrons. So nuclear number will be 6 plus 8 equals to 14. Therefore, atoms of the same element have the same proton number but different neutron. This is called isotopes. The use of isotope. First is a radioactive isotope, are widely used in medicine, agriculture, industry, and research. This type of isotope can give out radiation. The radiation can be traced or detected by suitable detectors. Radioisotopes are mainly used as tracer. Tracer isotope is an isotope used to track the movement or path of certain atoms or molecules in chemical process, biological process, and physical process. Medicine. The sodium-24 isotope is injected into a patient's body to detect the place where blood clotting had taken place, or the cobalt-60 radioisotope used to treat cancer. And the other part is iodine-131 is used to detect the location of tumor in the brain. So this is because tumor cell absorbs more radiation than healthy cells. And other than that, uses of isotope in the agriculture industry, petroleum industry, and automobile industry. With that, thank you very much for your time and listening. Hope you are very clear with the presentation of the subject matter. So you can get the detail or customized notes by clicking the link at Joan Stadila Instagram. Last but not least, please press the thumbs up, like button, and subscribe at YouTube, and follow me at Joan Stadila Instagram. Thank you.